Hello guys, my name is Muhammad Ali Takasha Aliman bin Budi Aliman, and today I'm going to introduce you to our project. It calls MANUBIPS, Manufacturing Bioplastic from Potato Starch for Sustainability Use. It's a project that focuses on producing biodegradable plastic from potato starch and environmentally friendly alternative to conventional plastic and this project aims to investigate the effect of glycerin on the mechanical and physical property of the bioplastic. Okay, so the problem is today's traditional plastic are made from oils, and it will take hundreds of years to disappear and often polluting our oceans, and this is called SDG 14. The solution is to use valorizations. Our project use food waste and science. The science is by turning it into 100% biodegradable bioplastic, and this is matter because it changed the way of thinking and support SDG 9, SDG 12, and SDG 13 and 14. All this is to make the world better, guys. Okay, that's all from me.
So, next is our methodology. First, the potato waste is extracted to obtain starch. After the extraction, we dry the starch. After that, we mix the starch with water, vinegar, and glycerin in a cooker. We heat and stir the mixture until it becomes thick. After that, we pour the mixture into a mold and let it dry at room temperature to form bioplastic. We prepare three samples. With different amount of glycerin. The first sample is 8.3 ml, the second is 16 ml, and the third is 24 ml. Finally, we test the sample. We check flexibility, burning time, bending, and water absorption. So, that's all for our methodology.
Hello, my name is Estelin Estebel Esim, and I will present the result of this experiment. So, this graph shows the tensile strength of the bioplastic for sample 1 until sample 3. Sample 1 has the lowest glycerin content, while sample 3 has the highest. As shown, tensile strength increases from sample 1 to sample 3. This is because glycerin acts as a plasticizer, improving the interaction between stretch molecules and producing a stronger and more stretchable film. To the bend test graph. So, this graph represents the flexibility of the bioplastic. Sample 3 shows the highest flexibility, while sample 1 is the lowest. This is because higher glycerin contents allow the polymer chains to move more freely and making the material more flexible and less brittle. This graph shows the burn resistance of the samples. Sample 3, which has the highest glycerin content, shows the highest resistance to burning. This is because glycerin helps improve the thermal stability of the bioplastic, allowing it to withstand heat for a longer time. So, next we move to water resistant graph. This graph shows the water resistance of the bioplastic. Sample 3 has the highest water resistance, while sample 1 has the lowest. This indicates that high glycerin contents help the bioplastic retain its structure better when exposed to water, resulting in higher weight retention.
Based on the result presented earlier, now let's move on to the discussion section. First, for tensile strength, the elongation increased from 0.008 meter to 0.0223 meter, which show the sample 3 is the most flexible. This is because it stretches more under the same force, meaning it is less stiff according to Hooke's law. Next, for the bending test, the angle increased from 130 degree to 170 degree. This indicates that sample 3 has higher ductility, meaning it can bend more without breaking. For the burning test, the burning time increased from 1.06 seconds to 3.10 seconds. This shows that sample 3 has better thermal resistance, possibly due to its composition or structure. Lastly, for water absorption, the value increased from 2000 to 4000. This means sample 3 absorbs more water, which suggests it has a more porous structure. Overall, the trend shows that higher flexibility leads to higher water absorption. So, even though sample 3 has the best flexibility and strength, it also has lower resistance to moisture. This project also supports SDG 12, reduce waste by using food waste. Next, SDG 13, reduce CO2 through recycling material. In conclusion, sample 3 show the best mechanical performance, but with higher water absorption, showing a trade-off between flexibility and durability.